Okay, this is Lesson 8, Algebra 1. We're going to talk about area today. Area of a closed sphere is a number of square units contained in a sphere. For example, this is kind of a weird shape. I started drawing these little squares in here that don't really, I know I've got terrible drawing, and I don't admit to being an artist. But, so you would count the square units, and every square has the same length, and it's 1 unit by 1 unit. So any area that's enclosed, you can measure the area by counting the number of units that fit in there. Now, if it's an unusual shape, you're going to have to do a little bit finagling and breaking it up. So let's just start with the basic. How do you find the area of a rectangle or a square? Simply, you look at this one, for example. If I break it up, I've got, how many units do I have going this way? I have 4. And how many square units do I have? 2. So I can simply do 4 times 2 will give me 8. Whoops. Will give me 8 square units. Abbreviate here. Or we can count the unit squares. 1, 2, 3, 4, 5, 6, 7, 8. Yes, so therefore an area of a rectangle is simply length times width. What about a square? We learned that a square is a rectangle. The only difference is all sides are equal. So you can do length and width, but because all sides are equal, we just call them sides. And we can say side times side, or simply s squared. Because isn't that what s times s is? S squared. So the area of a square is the length of a side squared. The area of a rectangle is length times width. If you forget, you can stick with the length times width. It's still the length times the width. The only difference between an area and a square is an area, all sides are equal, or in a rectangle, you have 2 different sizes. So let's find the area of this figure here. You have 2, 3, 4, 2, 6, 5. The first thing you want to do is you want to count how many sides you have in this figure. I'm going to use tally marks because that will help me to keep track of it, because I just have a hard time counting. 1, 2, 3, 4, 5, 6. Alrighty. So I have 6 sides. I need to make sure I have 6 measures. 1, 2, 3, 4, 5, 6 measures or length, or what size each side is. So I am good. Well, this doesn't quite fit in the realm of a rectangle or a square as is, but we do see some potential rectangles or squares in here. So we can break this figure up. We can either do it this way, and I've got a rectangle here and a rectangle here. Or I can go straight across this way and have a rectangle here and here. Either way it works, doesn't matter. What do you need? If I do it this way, I need a length times a width. Alright, do I have a full length? Yes, this whole thing is 6 units. And this is 2, so basically I have 6 times 2 is 12 square units. So I've got 12 square units in here. What about here? Well, I need this side times this side. Do I have it? I actually do. That tells me that's 3, and that's 2. So basically that's 3 times 2 is 6, and you add them together, and you get 18 square units. And when you're talking about area, it's always going to be square units. This happens to be centimeters, so you would write it like this, cm to the 2nd power. Okay, let's go on and do another one. Let's do one a little bit more complicated. So basically, when you're finding the area, when we did the 4 by 2, we said we could either do 4 by 2 or we could count each square, right? What happens when you count them? You're adding them together. So that's why it works when you break it up in pieces and you add all the areas together. Let's look at this one here. Okay? This is 6 and this is 2. And this is 10 and this is 8. I'm going to shade in. You're going to pretend like all this is shaded. Okay? And we said you can add up everything, break it up in pieces, and add everything together will total the entire area of this big square. So how do I find the area of just the shaded part? Well, I know I can get the area of the entire rectangle, right? So area of big rectangle. And can I minus the area of the small rectangle to give me the area of the shaded part? Yes, I can. Do I have enough information to get the area of the big? Yes, I have a length and I have a width. So I'm going to do 10 times 8, which is going to simply give me 40. Then I'm going to minus, what's the area of this little triangle or rectangle inside? 6 times 2, which is 12, which is 20, 28, and let's just call it inches, so it's going to be square inches. Okay, moving on. So you just need to learn that you add up all the areas together, and if it's an irregular shape, break it up into things that you know. So let's look at the area of a triangle and the area of a circle, or area of a parallelogram. So an area of a triangle is going to be 1/2 base times height. Now, let me give you this triangle here. This is going to be the base, and this is going to be the height. Now, how you can determine what the height and the base are, the height will always be perpendicular to the base. And don't forget, perpendicular means it makes a right angle. If it does not make become perpendicular with the base, then it is not the height or the base. So let's look at, let's give this some numbers. So 6 and 2. Okay, so I'm going to do 1/2 times 6 times 2. My 2's crossed out, so I simply have 6 square units. That one's pretty easy. Now let's look at 2 more types of triangles, different shapes. Let's look at this one. So if I give you remember, this little square means right angle. It means the 2 lines are perpendicular because they form a right angle. I said I need a base times a height. Is it going to be 4 times 3? No, because this side, is it perpendicular to this base? No, it's not. Therefore, that is not the height. The height is going to be this dotted line, which is 2. So you're going to have 4 times 2 times 1/2, or simply 4 square units. Let's look at a different one. Let's look at a scaling or obtuse. Okay, let's look at this one. This is my triangle, not the dotted line. Even though it makes another triangle, that is not our triangle. Our triangle is the full, this one over here. So what's my base? 6 is your base. But what about this? Is that my, do I add that to this 6 and make it 9? No, this is simply your base of your triangle from here to here. This is just an extension. Now, is this my height? It touches my base? No. What is the rule? It must be perpendicular to the base. That is not a right angle. Therefore, it is not the height. But if I extend out my base and draw from here to here, it becomes a right angle. This is just an extension of the base. You don't include it in your calculations. But the height does make a perpendicular line to it and is a right angle. Therefore, this is your height and this is your base. So you're going to have 6 over 1 times 4 over 1 times 1/2, or simply 12 square units. Okay. What about the area of a circle? So you need to write this area, this formula down. Area of a circle. simply, the area of a circle is going to be pi r squared. So you need a radius. What if you're given a diameter? Then you simply cut the diameter in half to get the radius. So if I give you this, and I say this is the diameter, and it's 6, find the area of that circle. Well, you've been given the diameter. You know radius is half of the diameter, so it's 3. So your area is going to be pi times 3 squared, or simply 9 pi. And you can calculate that with the calculator. I'm not going to do that here right now. What about the area of a parallelogram? Well, there's formulas for it, but we don't use them very often because they're pretty complicated and because it's just something we don't do. But what is another way? Let's look at this parallelogram and see if we can find the radius of this parallelogram. So if we take this and this, oops, and this. We said this is 8 and this is 8. And I give you from here to here, which is a height of 4. Okay, that's a height. If you draw a line and you extend this base out, it's going to be perpendicular to it, even though my drawing doesn't look like it. Well, what can you do? Can't you do this and make 2 triangles? You have triangle A1 and triangle A2. So if I got the area of this triangle and add it to the area of this triangle, I would get the area of this parallelogram. So let's look at that, A1 plus A2. Well, what is A1? What is my base? Well, it's going to be right here. It just happens it's a flipped upside down triangle. The base can be on top. It doesn't necessarily have to be at the bottom. We usually like it to be at the bottom because we call it base. It makes more sense. But it can be on top. So you're going to have 1/2. Your base is 8. And what's your height? Well, here we go here. We have an extension of the base, and this line is perpendicular to it. So this is our height. So simply, we have 16 square units. Let's look at A2. Again, you have 1/2 times your base, which is 8, and your height, which is 4, which is 16. So therefore, your area is 32 square units. It's as simple as that. You just add the 2 together. Let's look at another trapezoid that's a little different. These happen to be a rhombus, which we know rhombus means it's a parallelogram with equal sides, and so those are all equal. It looks like they're all equal. So let's look at this. Let's look at a trapezoid. Okay. Again, I can cut this into 2 triangles. I know the area for triangles, 1/2 base times height. So I can take A1, the area of triangle 1, plus the area, that's what that means, triangle 2, to get the area of the trapezoid. Okay? Well, A1, do I have a base? Is it 5? Do I have anything that's perpendicular to 5? No, these don't make perpendicular lines, so that wouldn't be my base. I have a 9, there's nothing here or here, but if I extend this line right here is perpendicular to it, so, and it goes to the bottom of this triangle, therefore, or I could do it this way. Right? I made a rectangle. What do we know about opposite sides? That's 4. This is going to be 4. So therefore, I have 1/2 9 times 4. Okay. Plus my second one. Where's my base? It's right here. So it's going to be 1/2 times 15. And my base, again, is 4. 2, 1, 2. So I've got 18 plus 30 which is simply 33 square units. So that's all you do, is you just simply break it up. And let's look at one more that's a little bit complicated. It's just an odd shape, and it looks something like this. Pretend like this is a perfectly semicircle. Okay, I want you to find the area of this. This happens to be in inches. Well, I don't have a formula for this, but I can do this and get a rectangle. I have a formula, a triangle. I have a formula for a triangle. I can do this. I now have a rectangle here, and then here I have a half of a circle. So I can take the area of this plus the area of this plus the area of this to get my area of this shape. Do I know what this base is right here? Well, I know that this whole thing here to here is 7. I know from here to here is 5. And what do I know about rectangles? Opposite sides are the same. So from here to here is 5. If I know this plus this little part gives me 7, this has got to be 2. 2 plus 5 has to equal to 7. So I have the base. What about the height? Makes a right triangle here, doesn't it? Well, I need to know this side. Can I get this side? Well, what do I know about a circle, even if it's a half a circle? If I extended this, then I know that this is a radius 2, and this will be the diameter. The diameter we know is twice the radius. Therefore, this side right here is 4. And because it's a rectangle, opposite sides are 4. So now I have enough information to do that. Okay, so we're going to take 1/2 times, use our formula, and I don't care if you write your formulas down, and keep them on your notes and you can use them for tests. I'm good with that. I just want you to know how to do this. Alright, so this is simply going to be 4. What is A2? A2 is a rectangle. You need a length and a width. Well, my length is 5 and my width is 4, so it's simply 5 times 4, or 20. And then A3, it's a circle. Don't I know the area for a circle? Of course. It's pi r squared. However, do I have a full circle? Do I want all this? No, I only want this part here. Therefore, I have to take that formula and divide it by 2. So what is it? So it's going to be pi times, what is r squared? That's 2. Times 2 is 4. So 4 divided by 2 are simply 2 pi. And you simply add these. It's 24 plus 2 pi. And you can add all that together and get 30.28 square inches. Okay? You can do 2 pi. Don't forget pi is equivalent to 3.14. That's all we have for area.